This is the brief on the geometry of motion and fictitious forces. So we're diving into that weird link between what you physically feel when something's moving, like that push in a turning car, and the really deep math that describes how we see that motion. First, these so-called fictitious forces aren't really forces at all. They're all about your point of view. Imagine someone standing still. They see an object move in a straight line. Simple, right? But if you're on something that's spinning or accelerating, that same straight path suddenly looks curved to you. That force you feel, like a centrifugal push, it's not a real push. It's just a mathematical patch we need to make Newton's laws work from your moving perspective. Okay, so how does the math handle this change in perspective? Well, second, that's where something called the Christoffel symbol comes in. Now, in physics, we love using things called tensors because they give us consistent results no matter how we look at a problem. But here's the kicker. The Christoffel symbol is explicitly not a tensor. It actually breaks those rules on purpose. And finally, that's the whole secret right there. Because it's not a tensor, when you transform it from a still frame to a moving one, an extra piece of math just pops up in the equation, and an extra term that shouldn't be there. That little bit of leftover math, that's it. That is the fictitious force. It's the mathematical signature of your acceleration. So the illusion of a fictitious force is just the physical result of a predictable mathematical quirk in the geometry of a changing point of view.